Hello, everyone. Good morning, good afternoon, good evening, from where you're watching this talk from. And of course, it's going to be up and live after this streaming as well. We from GDG Cloud London are very happy to have Contino speaking here today. We've been chatting with them for a very long time. We actually had an event set before everything happened. We wanted to go to their offices, and we hope we manage to go there once the world gets back to being world. But for today, we're very happy to have them here online. The topic today is Cloud Run, and I will let our speaker introduce himself and all this amazing stuff he's going to speak about.
Hey guys, so my name is Mihnea Spirescu. I'm a principal consultant with Contino, and today we'll be talking about Cloud Run, overcoming the challenges of building and deploying serverless applications. Thanks for everybody for joining us today. I hope everybody is safe at home. And I would like to ask you, if you have any questions, please leave them in the comments below, and our moderators will take a look at them. And at the end of the presentation, we can go through them and provide some answers to you. So first, let's start. So let's talk a bit about who Contino is and what do we actually do, right? So Contino is a global consultancy company. We worked with more than 150 of our customers. These companies range from small startups up the way to large financial institutions. These are household names. And usually we help them with on their journey towards their digital transformation ambitions, right? And this actually means a lot of the time we provide help with enterprise DevOps, cloud native consulting, and the cloud native platforms, and building data engineering platforms, right? We grew from one office and a handful of people 5 years ago to more than 360 people and 5 global offices. So if you need any help with digital transformation and support in building cloud environments on all three large cloud providers, GCP, AWS, and Azure, we're here to help. So a little bit about myself. I've been with Contino more than about 2 years now. And throughout that experience, I've been working predominantly on cloud platforms, mostly on AWS and GCP. And lastly, in the last couple of engagements, I've been working on cloud native solutions, basically bringing containerization to large financial institutions and implementing Kubernetes, both managed and unmanaged services to the customers. I have a bunch of certifications in the industry, both from GCP and AWS, and hopefully that will back up the experience that we have in Contino. So throughout these presentations, I usually like to provide some context. I don't like talking about technology just around features of a specific service, no matter what cloud provider we're talking about. And so I'd like to introduce a very fictitious company called WeatherRank. Right. So as any other company, these guys have some ambitions, but also some challenges, right? So let's start a bit with what are these ambitions? What are the ambitions of this fictitious company? So where they are now, they successfully migrated a few applications to GCP, but this was only made through a lift and shift pattern, right? So they haven't re-engineered their applications. They just shifted some VMs from on-premise and they deployed into a GCP environment. Their main consumer application product is a well-known weather web application, and this application will be using throughout our demo and the subsequent descriptions. And these guys are actually planning on releasing the new update for the application to leverage the cloud native technologies, and we'll see how serverless can actually help them. Like I said, like all our companies, they have some challenges, right? So this company also operates data centers around the world. And because they made huge investments in those data centers, they can't just throw them away, right? They have to find a way to leverage those data centers in order to provide the services. And lastly, the focus this year is to minimize the operating costs and speed up the development process. So behind any company, we always have some heroes. Today's hero is Tara. She's a DevOps engineer at WeatherRank. Just a second. She's a DevOps engineer. So Tara, she's a DevOps engineer at WebRink. She's been asked to look into how serverless architectures can help the company with this new application release. The problem is that she never used serverless before, right? So the first thing is, what now? So let's follow Tara as she learns how Cloud Run can help her deliver her new application. So as any good engineer, she'll always have a to-do list. So she'll start with why serverless? What are the benefits of using a serverless platform? We shall then try to understand a little bit about the capabilities of Cloud Run as a platform. Now, you can't understand a platform without making sure, and you can't provide a platform for an application if you don't really understand the requirements for your own application that you want to deploy. So we'll get a little bit familiar with the where application. And obviously, it's 2020, right? We don't want to hang crank the deployments into production, so we want an automated way to do serverless CI/CD, and with that, we'll be using Cloud Build. Now, at the end, we'll have 2 live demos. Hopefully, everything will work out, and we'll see how we can take an application from development up to production very easily, leveraging Cloud Run and Cloud Build. We'll end with Tara's key takeaways. These are some things that she learned throughout this journey in trying to implement serverless. So let's start with why serverless. And I think the best way to understand why we're here is by going a little bit back in history and trying to understand how we got here. So I kind of split these in 3 main periods, right? The old data center days, the great migration in the middle, and then serverless and beyond. So the old data center days, right? Applications are deployed on existing on-premise compute resources. Everything is siloed. The majority of large corporations still have separate development and operation teams. The engineering teams need to manage compute and networking infrastructure, and that adds a lot of complexity. And with that, it includes a very slow release cycle, which drives an increase in costs and creates a very risk-averse culture, right? And with that, it means that developers are not encouraged to try something new, add new features, in order to maybe find new ways to generate revenue for the company they work for. The Great Migration, right? This is the period where I think a lot of large institutions are. This is the period where you're trying to move your existing applications living on premises to cloud. And I think the main focus here is increased focus on application delivery and trying to minimize that time to market. A lot of companies are actually now focusing on cloud native applications development. These are leveraging containers and container orchestration tooling in order to speed up the delivery process. Now, one of the most important things with a cloud environment is the fact that it reduces the cost of operations by really taking advantage of elastic infrastructure. But really, I mean, that's all great, right? But at the end, they still need their shiny data centers. A lot of these companies, while they have cloud environments, being now GCP, AWS, or Azure, they still operate big deployments of data centers. And one thing we need to make sure is, while they're transitioning into the cloud, we want to make sure that they can still leverage their data centers. And lastly, we go into serverless and beyond, right? And this is the cool bit of history, right? Where engineers are now taking full advantage of cloud-native development patterns and practices. Applications are stateless and respond to events. Really, development velocity is increased as teams do not need to maintain the underlying infrastructure, right? You don't care about that VM, you just care about the execution of your function, right? It's serverless. And most importantly, frequent iterations means a better market fit for our products, right? The quicker we are to our customers, the better experience those customers get. And lastly, and probably the most important feature of serverless is the fact that you're built per execution of a specific function or container. And it has the ability to scale to 0, right? Everybody talks about scaling. I think one of the elements that kind of misses is the fact that it's also important to scale to 0, not necessarily to 100, right? You want to be able to make sure that if nobody reaches your service, then you're actually not built for that service, right? You have no consumption of that service in your environment. So this gets us to GCP, right? And GCP has a couple of options in terms of serverless platforms. So what should Tara use, right? So we have 3 main services that are considered serverless by GCP. First of all, you have Google App Engine, then Cloud Functions, and Cloud Run. Now, Google App Engine is a bit special because it really depends if you're looking at the standard environment or the custom one, right? The standard one is the one that we're talking about. This is the one that allows us to use to scale to 0, right? So this is the only one that actually scales to 0. But at the end of the day, both App Engine and Cloud Functions, the bigger problems with them is that the runtime engines that they use are very limited, right? So if you're using a programming language that's not supported by either of those, then you're out of luck, right? Now, with Cloud Run, one of the biggest benefits is it actually runs containers, right? And the biggest benefit of that is it allows to scale your stateless containers from 0 to as much as needed. But more importantly, is as any serverless platform is actually built for execution. So you're actually built only when that container executes, and when the execution finishes, you're not getting built. So let's step back a little bit and look at the general GCP compute options. But let's plot these from 2 perspectives. One is the operational overhead that we have on the x-axis, and then flexibility, which we have on the y-axis, right? And if we take at the existing ones, Compute Engine, while it's very flexible, we can deploy any programming language you want. It's basically a VM, right? We can do whatever we want with it. It has a lot of operational overhead. We want to make sure that we maintain the security of that instance. We're responsible for the operating system for every single application that sits on top of it, right? So it has a lot of operational overhead. Now, if we move into GKE, while it's a managed platform, obviously the operational overhead is less. But at the same time, that flexibility also drops down, right? Because if you cannot containerize it, you can't deploy it in GKE, right? App Engine Flexible is another option that we have for App Engine. So it's App Engine Flexible and standard. App Engine Flexible allows us to actually use containers in order to deploy. But again, one of the features that it lacks is the fact that it cannot scale to 0. It has to have one instance running at every single time. So let's plot where our serverless options come in, right? So we have App Engine Standard, while in terms of operational overhead is a bit less because we don't even care what's behind it. From a flexibility point of view, it's even less, right? Because we don't have the option of using containers. We have to be constrained to the specific runtime engines that is provided by the standard environment. Cloud Functions, it's even less flexible, all right? And this service in GCP is very polarizing. You have people that love it and people that hate it, right? It really depends how you use it and the use case you have for it. It's less flexible. It's a lot less flexible. You don't have enough runtime engines for a lot of applications. But obviously, because it's just a function and because it's a serverless application, it has even less operational overhead. And this is really where Cloud Run actually shines, right? It's really flexible because it leverages a container. Whatever you can bake in a container, you can use Cloud Run with. Obviously, it needs to be stateless, but that's not necessarily such a big problem in 2020. But in terms of operational overhead, if we're using the fully managed version of Cloud Run, then we don't have anything else to manage, right? We don't care about the underlying infrastructure. We don't care about the compute behind it, right? It's just a serverless platform that we can leverage. So Tara's first tip, right? The appeals of serverless platform is represented by the reduction in the operational overhead, right? And I think a lot of people are missing the point when they're leveraging services like GKE. While GKE adds a lot of benefits, I think people should give Cloud Run a try because for a lot of situations, Cloud Run can be a really viable option. So why Tara chose Cloud Run, right? Well, she's very comfortable with containers. Her company spent some time developing some applications. They containerize them, and they already have all the workflows they need for building, managing, and deploying containers, right? So if you're comfortable with the process, why change it, right? More importantly, it has per execution billing. So lowering costs for development environments, right? Which is really important, especially if you want to provide a live environment for every single developer. It reduces the operational overhead by not requiring net new cloud infrastructure to be provisioned, right? It's a fully managed service. But also one of the key differences between other serverless platform and Cloud Run is Cloud Run actually has the ability to work in both cloud, in GCP, or even on premises, right? And this is by leveraging Cloud Anthos. So we took it down to history, and we understand why we need serverless. We then took a view on where Cloud Run sits in terms of the compute options that we have. Let's dig a little bit deeper in terms of what Cloud Run is and how we should manage it. So if you look at the definition of Cloud Run, right, it's a fully managed compute platform for deploying and scaling containerized applications quickly and securely. And I've added one of the most important features of it, which is featuring paper execution and billing, right? So let's take a look at some of the more notable features, right? So first of all, it leverages container, right? And this means, as we said, that it allows us to use well-known patterns for building and managing applications, right? And more than this, there are existing tools that we can leverage in order to provide security scanning and trying to make sure that those containers are actually secure. If we look at other features, code revisions, it's one very important one that we'll leverage in our demos today. Every deployment that we create, it becomes an immutable revision for the Cloud Run application. It allows you to split traffic from multiple revisions in order to provide rollout versions gradually. But more importantly, it allows you to roll back. And we'll see how we can use this in order to build a Canary deployment. And lastly, one thing that I want to mention is Stackdriver integration. And I'm not talking just about logs, but the entire Stackdriver toolchain, right? So we'll see how we can do error reporting and debugger in order to understand how our application behaves and understand when something goes wrong, how we can get notified of those errors. Now, Cloud Run is actually based on an open source solution called Knative. And if you go to the Knative website, you can actually take all the Kubernetes manifests and actually deploy it in your own Kubernetes cluster. Right. So Knative allows the build, run, and management of serverless applications on any Kubernetes cluster. What Google did is basically, one, they outsourced Knative. They also built Cloud Run as a service, as a managed service, and then added all the sprinkles on top in terms of all the service integrations for Stackdriver and for Anthos. So we mentioned Anthos a couple of times, right? And why is that, right? So Cloud Run comes in two available platforms, right? We have Cloud Run fully managed, and this is basically the simplest one, right? Everything is fully managed by GCP, and we just deploy our applications in that managed environment. Cloud Run for Anthos, it's a really cool feature. It actually allows to deploy your serverless application in clusters in GCP, which is basically means Cloud Run for Anthos on GCP, or on-premise environments by leveraging Anthos clusters. So you can leverage the same build and deployment workflows to deploy on a fully managed environment, and then seamlessly transitioning to an environment that actually sits on-prem. So this is actually really, really powerful. And we'll see a demo of this later in the demos. Now, one of the more difficult quirks with Cloud Run is understanding the network access it needs in order to connect to your resources, right? So another of Tara's tip is network access between serverless applications and other resources is really important. Please choose carefully, right? So let's dig a little deeper and understand what are the problems with Cloud Run's network. So here we're only talking about the fully managed version of Cloud Run. We're not going to take a look at the Anthos one. But in terms of the fully managed one, you have to ask yourselves a few questions, right? So if we start from the left, you basically need to ask yourself, do you need access to private resources? And these are databases. These can be your other internal VMs in your VPCs, in your GCP VPCs that you use. So do you need access to those resources? If the answer is no, then you don't need to change anything. But if the answer is yes, now you actually have a couple of more questions, right? And the first one is, do you need to access a Cloud SQL instance? Or do you need to access any other resources, including Cloud SQL? And this is pretty important, right? Because if you just need access to Cloud SQL, then we have more questions, right? And you'll only find these out the moment you start actually implementing, right? So see this as just a shortcut to Cloud Run's networking. So if we have a Cloud SQL instance, does that instance have a public IP? And this is, for me, one of the deal breakers by using this arm of the decision tree, right? Because a lot of the clients that we work with, they would never want our Cloud SQL instance to have a public IP specified. Now, this doesn't necessarily mean that someone can reach your SQL instance across the internet, because it doesn't necessarily need to be whitelisted with specific IP ranges, but it still requires that public IP. So if you can support this, then the next question would be, can your application use Unix sockets to connect to Cloud SQL proxy? And this always comes back to, can you refactor your application, right? Can your application support a few changes in order to allow this functionality? If you can, so if you have a SQL instance with a public IP, and if you can refactor your application to read from sockets rather than from an IP, then you can actually use Cloud SQL proxy and configure your Cloud Run with a connection to your Cloud SQL instance. And what actually happens behind the scenes is when your Cloud Run application runs, they will mount a specific socket that you can connect to for your database. Now, this always adds complexity. So if the answer at any point was no, or you require to connect to services that are not necessarily Cloud SQL, then the easiest option, and the one that I recommend, is basically configure a serverless VPC access connector that we have here at the end, and configure your Cloud Run application just to use the just configure connector, right? This means that any connection to your private services will be using a private IP address range, and your services can reach the required services without needing to use sockets, without needing to have public IP addresses, right? Now, the reason why this is a thing is 6 months ago when I started working with Cloud Run, VPC access connector, serverless VPC access connector, wasn't available for Cloud Run, right? Now that it's available, I don't see a point why not using it. Cool. So convinced that Cloud Run can fit the requirements of the application, Tara decides to run a POC on the implementation. So before we make a decision, we always need to take a look at the requirements of our application, right? So let's understand a little bit more about what this weather application is and how it looks like. So this is a very simple Node.js-based application. It connects to a PostgreSQL database. One of the two requirements that they have is that this application needs to scale up quickly. But lastly, and probably the most important one, is that the production version of the application needs to be deployed to an existing infrastructure that it's approved by the security team. And to be honest, this is something very common, right? You want to give your developers the ability to develop new features as quickly as possible and iterating over your application as quickly as possible by creating new features. But at the same time, you want to make sure that from a security standpoint, everything seems okay, right? So you want to make sure that you're deploying in a very consistent way in a security-approved environment. And in our case, this will be a GKE cluster. So what GCP services are going to leverage today? So obviously, this entire talk is about Cloud Run, right? So we'll use Cloud Run as our compute in order to serve applications to our customer. For our PostgreSQL database, we'll use Cloud SQL. And for building, basically the CI/CD side of things, for building the container and then deploying that to Cloud Run, we're actually using Cloud Build, which is a fully managed continuous integration and delivery deployment platform. Cool. So we talked about this application. We know that it's a Node.js application. How does the architecture look like? So it's rather simple. We have our customers on the right, and we have the development with the desktop and the mobile application. It connects to an URL, weather.experiments.dev. which then points to a Cloud Run application that connects in turn to Cloud SQL. Now, one of the things about any Cloud Run architecture is that we abstract away a lot of the complexity, right? So in our case, depending on the environment where we run, Cloud Run might be fully managed or might actually be backed by a GKE cluster. And we'll talk a little bit about when do we use that. Now, obviously, we look at this and we say, oh, this is super simple, right? But what about? And then what about environments, right? So what environments am I going to use? So for this, for Tara's experiment, we're in the POC, we're going to use 3 different environments. So we'll have development, staging, and production, like pretty much any other company. In terms of networking considerations, right? It's important to mention that we'll have some slight variations. In the development environment, because we're going to use a fully managed environment, we'll actually use the serverless VPC access connector, which allows us to connect to our Cloud SQL instances. But for staging and production, these environments are provided by a GKE cluster, both one for each environment. And because these are deployed in their respective VPCs, it means that networking is handled by the cluster itself, right? So you will have to handle it the same way you handle any deployment into a GKE cluster. And secrets. Throughout these demos, Tara will have to, one, secure the database passwords, but also the passwords for the upstream services. For example, we're going to leverage an API for getting weather data, right? So the tokens needs to be secured. So in order to help with that, we'll use the GCP's secret manager with the secrets configured in each specific environment for each environment. Now, obviously, we can't deploy manually, right? And this is something we strongly disagree with, right? We want to make sure that we're deploying in a repeatedly and consistently way in order to deploy our applications in a consistent fashion, basically. So let's talk a bit about serverless CI/CD with Cloud Build. So no infrastructure to manage doesn't really mean there's no need for DevOps engineers, right? So, and the reality of it is that quicker iterations and faster time to market really amplifies the need for mature development practices. So let's set out a few principles before actually going to the CI/CD bit, right? So what we want to do is enable our developers to quickly and cheaply test new features, right? All code changes are propagated through an automated release pipelines. We don't want to manually deploy to production. We don't want to jump the staging environment, right? Everything should go and everything should be propagated automatically to that release pipeline. And lastly, you want to make sure that production releases are done in a quick manner, but also, more importantly, we want to make sure that they're safe. So let's talk a bit about the development workflow. So first of all, we're leveraging containers, right? So this actually means that I can build a container and I can test the container locally by just running the container I just built. Obviously, there are considerations around that. You need to make sure you have all the upstream dependencies connected. And in some cases, it might not be available, right? But at least it gives us the option to run that container locally. In terms of review, once the code is ready for a peer review, you issue a pull request, and you want to have the ability as a reviewer to see the code running before actually merging into master, right? You want to have a live environment of that application running before actually having the ability to merge. In the staging environment, once we merge a PR in master, we want to deploy that to the staging environment. One thing to mention is that we want our container builds to be consistent and immutable. And at the same time, we want to make sure that we're deploying the same artifact from staging to production, right? So we don't want to rebuild that artifact. And more importantly, the staging and production environments need to be as close as possible to each other, right? We don't want to have configuration drift between those two, right? And that's why for both staging and production, we'll use a very similarly configured GKE cluster. And the last step is production, right? We want to make sure that we have a way to deploy to production. And in our case, in these demos that Tara made, we want to be sure that we are deploying based on tags. So once we have an application deployed in the staging environment by using the latest in the master branch, if we tag with a specific release version or one commit, then that gets deployed to production. So let's look at this from a different perspective, right? So what are the projects in GCP that we're going to use, and what Git branches are used for orchestrating our deployments? So in the first phase, the development one, we use our local development machine. This is by building and running your own containers locally. If we actually want to have PRs and we want to actually deploy this in a fully serviced environment, we can use the development project. And we're only looking at the Git branches that start with dev dash. So you can have dev dash feature, and they get actually deployed as an application in Cloud Run. And this allows other peers to basically review that, make sure the application works, or you as a developer have a way to test this application in a development environment. For review, it's very similar. It's in the same environment, in the same branch. We just give you the ability that in the peer review, you can actually go to that build process and see the specific instance of application running. So you can, one, check the code, make sure the code is correct, but also have a live environment to check. In the staging environment, we're going to use a completely separate GCP project called staging. We have automated builds and deployments into this environment, and we'll be taking the code from the master branch. So once the code gets merged into master, we're going to deploy that to the staging environment. And lastly, the production one. So obviously, this uses a very different project called production. It would still use the same commits from the master branch, but this time you'll only deploy the ones that have been tagged with either a semantic version with v star, whatever the version would be, or we'll have Canary deployments where we can have a Canary-v with a similar named version, which allows us to deploy a Canary version for that specific iteration. So from a branching strategy, visually, how does this look like? It's pretty simple. We first have one specific version on master. Tag v1 is deploying to production. We have master, which is deploying staging. Our dev key feature will be deployed in the development environment as a live environment for this new feature development. Once this gets merged into master, it gets deployed into staging, and once it gets tagged with a specific tag version, it gets deployed to production. So what are the tools that we're going to use? So all the code is stored in GitHub. I'm not going to go into details what GitHub is. I assume everybody knows. It's a widely used version control system. For our build process and deployment, we're going to use Cloud Build. And in order to store our container images, we're going to use Container Registry. Our Container Registry has one really neat feature, which allows you to perform vulnerability analysis on container images. So what are our triggers that we configured in Cloud Build in order to automate this entire process? So we have 4 of them. First one is the one that triggers on any push to a branch that matches this regex, this filter. So once a commit comes from this specific branch, you'll actually deploy a new version in the development environment for your Cloud Run application. Once a PR is merged into master, you can only push to master if you actually have a PR, right? That should be pretty standard. Once that gets merged, we deploy to the staging environment. If we tag with the Canary tag, we can deploy to the production one, the production environment using a Canary version. And then if we tag it with the semantic version, we're just going to deploy fully 100% of the traffic to production. Now, one thing to note is throughout these, they will leverage different Cloud Build manifest files, running reusing the same one, because this makes it easier, one, to demo, but also to keep the separation between those triggers. So visually, how the deployment process will look like. So for the development environment, once we have a branch and we commit a branch to Git, to the source control repository with dev-star, in our case can be dev-feature1. When we commit that branch, it triggers Cloud Build Cloud Build runs in a shared services project, and it will deploy a version of that application inside the development project, which means that we'll have a live application with the name dev dash and the branch name. In our case, would be dev something, which allows us to test, verify, make sure everything works as expected. Now, the beauty of this is, as another developer starts working and he creates his own branch, we can actually have multiple parallel deployments, right? Everybody working on their own branch, every developer will end up having their own environment to test the application running end to end. So how does the process look for staging and prod, right? We said that we're going to leverage Cloud Run for Anthos and on GCP, which actually uses GKE. So how it's going to change our deployment process for both staging and production, because they're as close as possible. So really, not that much from a deployment perspective. So as we said, for both staging and production, we're going to use a GKE cluster that has been configured with Cloud Run for Anthos. And the only thing we're doing in our cloud build process, we're actually specifying that we want to deploy to a GKE cluster. And the cluster itself has been configured with the necessary information to know that this application will point to a specific URL. And in this case, will be stage.weather.experiment.dev. For production, it's exactly the same, right? Cloud Build won't necessarily rebuild the same container, but will use the already built running container running staging and will deploy that to the production GKE cluster. And this one has been configured with a different URL because this is the actual application that our customers will actually run. So let's look a little bit about feature deployments and actually go to our first scenario / live demo. So feature deployments, what are we going to cover in this demo? So we'll talk a little bit about deployment of a new feature of our application. We'll be triggering a deployment from a development Git branch. We might or might not have some issues. As we all know, live demos always go bad, so we might have some issues. So we'll try to fix it and then push an update. And what we expect is the application to be redeployed under the same branch, and the problem should be solved. But at the same time, we want to leverage some of the existing services that GCP provide, things like Stackdriver logging and error reporting, in order to get some insights about where our problem actually lies. So let's start with the demo. So I have my application opened here. It's a very simple Node.js application. It has a couple of views. Nothing really stops you from deploying this to storage bucket. But for the sake of this demo, we're going to deploy it Cloud Run, built inside a container. So we have our application. Let's actually open the. Let's actually see exactly what we're dealing with. So if you look at our production application, this is the famous weather app. And all it does, if I give it a specific location, it will show you how many degrees are in that location. And I chose Chicago for this one, and we'll change it to something different when we're actually updating the application. So as we can see, we have weather.experiment.dev. You can actually reach this URL if you want. But the application is up and live and running. Obviously, because it's running inside a serverless application, the first time you trigger a request, it takes a little bit more time. But afterwards, it's almost instant. So we have the weather.experiment. This is production. We then have the stage one, and obviously it's the same application. So it looks the same. And currently it's pointing at the same version of our application. If we go back to Cloud Run, keep in mind that we are under the development project, and we see you already have some versions of this application running. And if you look at the URLs, they kind of match with some of the branches that I have in my code, right? So I've currently, as I was working on this demo, and as Tara has been experimenting with it, we've been creating some branches, trying to make sure everything works as expected. So what we'll do today is look at our application. I just created a new branch, dev GDG UK demo. This branch is not really here, so this application has never been deployed. So no cheating here. So what we'll do is I'm going to change the city from Chicago to London. All right, small change, quick fix. That's what I'm going to do today. So I'm going to add my changes. Change of location. All right, so I'm just a developer working on this application. So once I build this, obviously I'm going to push it. As you can see, this branch doesn't even exist yet in my source control. So that's the title of our talk. Let's try that again. So all we're doing now is just pushing a new branch, right? So if we go to, actually, it's a good point. I haven't saved the page. And as every good developer, I just got V2. Cool. So we actually pushed our update with London. So if we now go to, right, so you can see there's a new branch. And we can see that our build process started. So as we said, our cloud build has been configured with a couple of triggers. And these are the triggers that we talked during the presentation, right? So we can see push to dev. And we can see all the changes here. So now if I look at the running builds, so I've committed 2 times, right? First one was when I forgot to add all my changes. I've made some secret changes behind the scenes, but I forgot to add my location change. So this will run. If we look at this specific trigger, all we are doing here is building a Docker image, and we'll take a look at the manifest afterwards. And then we're actually deploying this application to Cloud Run. So to see this more in a better way, let's go to our build, cloud build manifests. And as I said, the only thing we're doing is we're building a container and pushing that to our GCR registry, and then we're deploying to Cloud Run. Things to mention here. As you can see, we're deploying to the branch name and then the repository name. We have a very specific image that we just built in the previous step. We're using the platform flag with a value of managed, and we're adding the VPC connector. So we know that in the beginning we talked about network connectivity for Cloud Run, fully managed, and we previously created a VPC connector, and we're passing this and the name of the connector in this deployment to make sure that this application has access to the to our Cloud SQL instances, right? And as you can see, we also passing a couple of environment variables. First of all, are the secrets for database. We don't want to have the database version, the database password in the version control system, but also the API key, right? That's a secret that also needs to say in secrets manager. Now, one thing that we're also adding is the service account that will have access to decrypt these values and take them from secrets manager. So if we go back, we see that this specific step has been executed correctly. It finished. And if we look at the list, we can see that also this finished 7 seconds ago, right? So let's go to our services. Let's refresh this panel. And we see now, rather than having 3 instances, we actually have 4. And the one that we're interested in is the GDG UK demo web app. So we took it from our code running locally to building it and deploying it to Cloud Run. This is fully managed. There's nothing that I manage behind the scenes. So if you look at the revisions, because I did 2 commits on the same branch, it actually deployed two of these versions on the same application. The application is called dev GDG UK, which is the name of our branch. So let's actually go to this application. So we have the URL. This URL is open for everybody to click on it. You can actually scope the permissions to it, so you can only allow the people from your organization. But for this demo, we didn't go into much detail. And we can see that some variables have been set up, and these are the interpreted environment variables that we are setting up through Cloud Build. So we can see the secrets, but then we also have the IP of the database, the connection type, and the name of the database. So if we go here, and this is our application running only for just the servers. The first time you run an application on any serverless platform, it will take a bit of time. Oh, unfortunately, we have some errors, right? As you might expect, this is kind of the way we want it to happen. So let's take this advice and check the error reporting. So if we go back to Cloud Run and we go to error reporting, so this is part of the Stackdriver toolchain, and we see that automatically it read the runtime of the specific container and actually found an error saying message has not been defined. And we can see that this was last seen just now, and it returned a response code of 3 or 4. So if we click on this, you can get some more details. And we can see that, of course, reference error message not defined, and the problem is in routes.js on row 29. So I didn't have to do any configuration. This came out of the box when I'm running this environment. So let's get back to our code and see where the problem is. So message not defined, row 29. So we're expecting a message here, but this message is not defined because we made an error. So this is not message, it's spelled wrong, right? And as any developer will tell you, we'll always find some of these issues. So I think we fixed it. We saved the file. If we do a git diff, we can see our change. We made change from message for message. Git add. So all I'm doing is pushing commits to my own branch, right? I'm not deploying to other branches. I'm not changing anything. I'm just changing my own code from my own branch, right? And this is a pretty normal developer experience, right? You make some changes, you might test locally, but then at some point you want to make sure that your application runs in the context of your environment. So as you expect, what this will happen is trigger another build. You can see that the reference, again, is that branch. It was triggered by the specific trigger, like all the ones before it. And on average, takes about 2 minutes to run this application. So rather than looking at the execution of this specific cloud build step, what I want to show is something a bit different in Cloud Run around networking. Oh, and actually, while I was talking, we can see that actually it's redeploying already built a container, and now it's actually creating a new revision for us, and it just finished. So if you look at the revision list, we can see that just now it deployed a new version of our application. So if we go just to the same URL that was failing before, again, it shut down that old container, it will trigger a new one, and voila, it works. And now we have our application running. So as you can see, our branch, it's using a different location, giving London and a different background. If we go to the staging environment, we can clearly see, even if I refresh the page, that it's definitely using a different version. So as we take a look at our Git repository, we can see that we have our branch here. Let's actually make a pull request. I don't have the permission to push directly to master. You should never do that. I'm not going to bother with the message, but you should. And I want to highlight some things. So at every single commit, because we're actually running Cloud Build and because it has integration, we can actually see that not only in some cases, you might need some other people to review this, but I also have some checks defined. And these checks are actually the build triggers that we define. So because there was a build triggered by providing this change, now we can see that the build passed and it was able to deploy it, right? If you include some sanity tests or smoke tests or other testing suites you might want, you can actually incorporate these in your build process, which means that if you fail some of the tests, your application will fail and you won't be able to merge into master. So let's go back to the presentation. We'll leave this as is for now. So let's go to scenario 2. So scenario 2, smoother updates. So we saw how you can take a simple development environment from your own computer and push it to Cloud Run, which means that every single developer can have access to a managed environment, right? But what else? What if we want some smoother updates, right? What if you want deployments to production to behave a little bit differently? You want to have Canary deployments, for instance. So in the next section of our demo, we'll talk a bit about the differences between Cloud Run and Cloud Run for Anthos and how our deployment scripts actually change. And we really explore rolling updates with Cloud Run by making the production deployments to leverage Canary deployments, right? So we'll actually, for the new Canary version, we'll deploy 25% of the traffic. Once we confirm everything is working, we'll shift 100% of the traffic, all by using Git and basically Git tags throughout this process, right? So we're not touch any manual configuration of these services. So how does our branching strategy actually change? So the only big change is that we'll add a new tag called Canary v1.2. And in this case, the moment we tag a specific master commit with that, we'll deploy the Canary version and we'll only shift 20% of the traffic to it. And then if we tag the same commit with v1.2, we'll actually deploy the full version, the full traffic, and to that specific version. So visually, how this looks behind the scenes, we're going to tag our application. This is how we have it right now. So we just tag with v1.0. It shifts 100% of the traffic, and we can see it in weather.experiments.dev, right? This is the baseline. But by adding a new tag, which is the Canary-v1, it enables us to trigger a specific cloud build that will deploy another version of the application in parallel under the same Cloud Run application, but it will only shift 20% of the traffic, which means that in some cases, if you want to have multiple versions or test different versions, you can extend this with how many viable versions you have. Once we prove that we can pretty much load balance between those two versions, and we should make sure that the application responds correctly, then all we're going to do is shift the traffic to the new version to 100%. So we've seen a snapshot of that Cloud Build script, how it looks like in terms of the deployment process and what commands actually using. This is pretty simple. The only difference is that we're using platform managed, and then we're giving some information about that. But in terms of running Anthos for GKE deployments, Cloud Run for Anthos on GCP, what it actually means is everything stays the same except a couple of flags, right? So we'll have, rather than platform managed, we'll have platform GKE, and then we'll have to point to the specific GKE cluster and the location of the said cluster, right? So super simple. There's no big change in terms of how we deploy to those two platforms, but it's really powerful because this can also be an actual Anthos cluster inside an on-premise environment, right? So the deployment process stays the same, but we actually do it in a way that allows us to manage the same deployment practices. So again, demo time. Let's go back to our application. So we're here. We kind of validated the fact that our staging application looks a bit different right now than our feature branch, you can call it, right? So we want to promote this across environments, right? So let's go to our branch. Let's assume our manager approved the commit and our build was successful, as you can see here. So let's squash and merge. So once we merge this, our expectation is that this will trigger a build and will deploy to the staging environment, right? Because we want to make sure that everything that's in master is deployed to the staging environment. So let's go back to cloud build and look at the history. And what we can see here is that we just triggered a build automatically. This is using a different trigger. It's actually listening on the stage one, but it's using the master branch this time, right? So if we now we switch from the development project to the staging one, this is a bit different now because we have this stage weather app. We only have one application, right? We don't have multiple versions of it in this multiple applications, right? We have multiple versions of the same application. So if we go to Cloud Run for this application, and we go to revisions, we can see that throughout this demo, I've deployed this a couple of times, but currently it's pointing to 100% of the traffic to a version that was deployed 3 hours ago. Now, a few important bits and pieces. Now, this is different because now this is not deployed into a fully managed GKE environment. This is actually deployed in a GKE cluster. So if I open this Slack, this is actually using a staging cluster that I've deployed in this environment. And my engine is a bit slow. So as you can see, we have a cluster called staging. And the only difference from a normal cluster, so the only thing that you actually need to do is enable Cloud Run for Anthos. And this is a flag that you can enable. And this enables the deployment of the Knative components into your GKE cluster and all the other components that is required to allow this seamless integration between Cloud Run and GKE, right? So this was a cluster that was built previously. And if we look at our workloads, and this is where it gets a bit interesting, is because now we own the cluster where this gets deployed, we can actually see what types of workloads are running. So if we look at here, we can see that there are a couple of stage weather app deployments, right? So you can see that these are workloads and these are type deployment. And we can see that actually now that I have a fourth one that has one pod running, the other one has 0. Now, this is serverless, right? So if we're not using this application will actually scale to 0 pods, right? So let's see what 0.4 deployment is. So if we refresh the page, as we've seen in Kubernetes, we have 4 deployments, and I refresh the page, and I can see this new version of the application deployed 1 minute ago. So this URL matches with the one that we have in the stage environment. So if we refresh this, our expectation is now this is pointing to the new version of the application. And hopefully, if I haven't made any mistakes, that'll be the case. And voila. So now your staging environment reflects one of your feature teams, right? One of the feature builds. Cool. So seems to be working. Everything is in order. Let's deploy this as a Canary deployment into the production environment. So if I do git tag, so let's tag this with a Canary version of 3.0. So let's say we made some really good changes and we're going to deploy, we tag this. Oh, actually, let's confirm. I was in the wrong branch. All right. Let's call it 3 point. At this point, it doesn't really matter that much. So actually, I made a mistake here, right? So I added the tag to my dev GDG demo, but this shouldn't necessarily be a problem, right? And the reason for that is in our cloud build. So if you go back to cloud build, yep, we will see this application being deployed. So while this runs, it's important to mention the fact that if we take a look at our deployment manifest, so you can take a look at here. We're not actually, we're only rebuilding the, we're not rebuilding the container. All we're doing is adding that specific tag to the end of your deployment. And then we are deploying this into the GKE environment. So in this case, the platform now changes to GKE, and we're actually pointing to the production clusters. Now, one very small difference between this and the staging environment is we're going to deploy this application with no traffic, right? So the first time we deploy this, we're deploying with no traffic, meaning that this is a new version that we run in production. But then what we do is we look at this version that we just deployed, and we shift a percentage of that traffic. And in our case, this would be 25%. So now if we go to, right, so this was finished, and we can see that it's been deployed serving 0% of the traffic, and then we shifted 25% to the latest and 75 to the old one, right? So if we now go to the production environment, we should see a couple of things. So we now see that we're shifting 25% of the traffic to the new version, and for the old one, we're actually using 75. So if we go to the production application, again, we're splitting two different containers. We can see that now we're actually load balancing between them, right? And as I'm refreshing, in theory, it should be 25% to the new application and 75 to the other one, right? So as I'm refreshing, we kind of see this change. Now, once we're comfortable with our application as running in production, in order to quickly go through this, what we'll do is tag this with v3.1. We're having the same commit, we're not changing the commits, and then we're pushing this new tag. Now, what this will do in the background is rather than shifting 25%, it won't redeploy our application, but what we'll do, it will go to our cloud build. So this triggered, as you can see, this is using the other trigger called prod. It's using the tag v3.1. And what this will do is go to your GKE cluster and will shift from 25% traffic to 100% to the new version. So it's not actually redeploying the application, it's just making a configuration change. So if we go to production, and this shouldn't take that long. And similarly, in the production environment, if we go to production, we have a GKE cluster, and we can see our weather app deployed in the production cluster. This is the same. When you deploy and when you enable the Cloud Run on your GKE cluster, it actually deploys all the Knative components like Activator, Autoscaler, and there's another one, Webhook. These are all part of the implementation of Knative, and these are running as deployments inside your service, right? And there's another one, storage version migration, given those namespaces, right? So as we So one thing to mention here is the fact that if you look at here, there's no pods running. And again, as we said, this is a serverless environment, which means that if there's no request, it actually doesn't even spin up your pod. And one other important consideration to note is the fact that If you're deploying on GKE for Anthos, this means that in this case, you're actually paying for the underlying infrastructure, right? So you're not actually billed for execution. In this case, you are billed because you're building in your own GKE cluster and you have to pay for the resources you use, right? So there are very different use cases when you use one versus the other. Our case that we made is that we want to deploy this in an approved, security approved cluster. So as our build finished, right, it was successfully finished. We can see it's the one that triggered on pod on vTrag 3.1. If we go on an application in production, we can see that our traffic now has been shifted. We don't see another deployment, right? We see the same application that was deployed 4 minutes ago, but this time our traffic is shifted 100%. So if we're lucky, if we approach this page, we shouldn't see the old version pointing to Chicago, right? So this application now points to production. So let's go back to our meeting and end soon. Cool. So we've seen how we can take an application from development up to production just by leveraging Cloud Run, and by leveraging Cloud Build, we can take a container from our own environment and push it to different types of environments in Cloud Run. One, for development, we can use Cloud Run fully managed. This allows us to have as many application environments as possible, while moving to Anthos, and Cloud Run for Anthos enables us to run the same workload in a GKE cluster, living on-prem or on GCP. So a couple of key takeaways. If everybody asks you what's Cloud Run, really it's serverless. It's a serverless platform with batteries included, right? It has a lot of integration with a lot of the GCP services, right? So we've seen Stackdriver, we see the error reporting, we've seen how we can leverage those tools in order to have a very seamless operation of our services. If you need to run stateless containers, and stateless is a very important keyword, and want to abstract away all the underlying infrastructure, choose Cloud Run, right? I've said in the beginning of our talk that if you want to run a container, try Cloud Run first, right? Because running on GKE a lot of times comes with a lot of complexities. Even though it's a managed service, it comes with a lot of complexities of managing GKE as a service, right? So if you just need to run a container that has access to some database, and that container is stateless, give Cloud Run a try. It's really important to choose the right platform, right, for Cloud Run. If we're talking about the fully managed one and for Cloud Run for Anthos, because it always has a cost, security, and networking implications. We've kind of discussed about networking and security. I think cost is another aspect of it. Anthos comes with a cost, right? It's not free. I think it's in trial right now, I think until end of August, but afterwards it will incur costs. So depending on what type of Anthos deployment you're running, if it's on GCP or it's on-prem, it's a big difference in pricing there. And during the demos, we were deploying production using Git tags. And as you've seen, I just made a mistake right there. So it's really important that to mention that this might not necessarily work for everybody, right? There are some ways to make tagging a little bit more secure, making sure that you're signing specific tags. To make sure that not everybody can just push a tag and deploy production. But at the end of the day, this process can be extended to using release branches, can be deployed in many different ways, depending on how you architect your branching strategy, right? That was it. I think I went a bit late, but hopefully you guys can have some questions now. So let's take the first question from Mark. Can Cloud Run link with Firebase? Yes, it can. So yes, it can. The only challenge with that is, so Firebase, it's actually a completely different service from Google. It means that in order to access a database, it actually goes over the internet. So there's no private connection, as far as I could tell. There's no private connection. So you'll actually have to use an internet connection to the Firebase endpoint, and then it allows you to consume that service, right? But it really depends on your environment. If you want, yeah. Are there not any security dead spots in the cloud for secure data? I don't really know what you mean by that, but keep in mind. So one of my pet peeves with this, with Cloud Run initially, was the fact that it didn't have any way to connect with using private IPs to your own workloads, right? From my perspective, with the added serverless VPC connector, now you can basically use private addressing space to access your resources, which means here the connection between those services is completely private, right? Obviously, you always have to make sure that you're encrypting and you're using secrets manager for any secrets you're actually using in your application. Yeah. Other than that, I don't really know exactly what you're referring to. How's the networking like? Can it link to shared VPCs? So it's a really good question. So yes, it can. So think of it about how Cloud SQL actually runs, right? So for everybody who isn't aware, Cloud SQL instances are not actually deployed in your own VPC, right? The way this works in the background is that Google has their own VPC, private VPC, that then they peer to your own VPC in order to give access to your Cloud SQL instance. When you deploy a serverless connector, it actually gives you the ability to connect to a specific VPC, but also it means that all those transitive connections actually work, right? If you have more complicated environments where you have basically a middle hop between your networks because they're peered, then it won't work, right? Because we all know one of the most important rule is you don't have transitive peering between connections, right? So you can't jump between different VPCs. You might be on mute.
Oh, sorry about this. So thank you. You took all the questions actually. So thank you very much for. There is one final one here. Thank you very much for taking all the questions. I think we're a bit almost over time, so maybe only this final question for Mark, if you still have time.
Yeah, definitely. So should you start use Firebase or Cloud Run to keep the cost low but all future scalability? So I would say Cloud Run, right? So it depends on the use case you have. I would say you try Cloud Run, right? It's a serverless platform. Serverless as a technology, it doesn't really matter what cloud provider you're using, right? In terms of feature set, in terms of the fact that it can scale to zero means that you only pay for execution, right? As a concept has been proven many times, right? So if you look at companies like a Cloud Guru that provides video training for cloud topics, like AWS and GCP certifications, they were very well known for the fact that they were the first that were using serverless for running their entire operation, right? So I would say use Cloud Run, mainly because it gives you a lot of flexibility, right? If you're choosing for flexibility, choose Cloud Run. It gives you the necessary flexibility to build your application in a containerized fashion. And then it gives you all the ability to then connect to any other services that you might have in the future inside of a GCP environment.
Thank you so much for taking all the questions tonight. And we look forward to receiving you again here at GDG Cloud London.
For sure.
Cool.
Thank you very much, guys.
If you would like him to come back here, just let us know what else you'd like him to talk about to us. Thank you very much for your availability and quality talk tonight.
Thank you. Have a nice evening.
You too. Bye. Bye, everyone.
Cheers.